Hello and welcome to part 2 of our instructional video series on the Ultimaker 3D printer. To recap from part 1, we talked about the Ultimaker 2 and the Ultimaker 2 Extended. We covered their primary difference, being their build volumes, as you see here. We learned how to utilize the Cura 3D printing software. Most importantly, we brought a very fancy chicken to life. And we also briefly covered these parameters within the Cura software. For this second part video, I'd like to go in depth, altering each of these one by one and showing you the result of the part. To begin, I drew a 1.5 inch diameter sphere to have a very consistent and simple part to use. And then I loaded into Cura and printed it over and over and over again, each time varying one of the parameters so we can best learn its end effect on our future prototypes. After completing the print, I had my fleet of test parts ready to go. I brought it to the machine shop, wanting to get to the inside so we can show you a little bit more detail, and learned an interesting lesson, that the speed of the blade and the PLA material leads to melting, and therefore a bad test part. So, I put some elbow grease into it, found out another way how to cut it open, and applied that to the rest of the parts. So now we're ready to go through it one by one. Here I'm showing what I call the control for this group of test pieces, and here's what the output looks like. You can see that it created a very smooth surface finish with rather good resolution. You can observe there's support material underneath the underside of the ball, and you can see that there's a brim, a very thin layer of material at the bottom here that I'm flexing. You can appreciate the thin layer of the brim by seeing its transparency, and I hope you can also appreciate the resolution of the surface of the ball. Next up, I tripled the layer height. The most noticeable result of this was the much more poor surface finish quality of the part. That being said, the part did complete in about a third of the time, but you can see we paid a price. Also, without the support material on the base, you can see there's distortion underneath the overhang. When opening the part up, we can appreciate the 20% infill for what that means, and we can also appreciate the poor surface quality, as you can see areas of light shining through the walls. Next up, I tripled the wall thickness and returned all their variables back to baseline. You can appreciate right off the bat the surface finish has returned to a high quality. Additionally, without any support material at the base, you can see the part gets distorted underneath the overhang. You can also see there's a single layer which makes up the brim underneath the part. And to really get a better sense of wall thickness, we've got to crack this one open. Now that we have the part open, you can immediately appreciate the infill density of 20%, which you're growing accustomed to seeing. Also, you can appreciate really what wall thickness means, as shown here. More or less, it's the thickness of the shell in the horizontal plane, and when comparing it to the former part, you can see, as expected, it's just about 3 times as thick. So, next up, we'll increase the top to bottom thickness by a factor of 3 and return everything else to normal. You can see the surface finish is smooth as expected, no impact there. You can see that without the support material, there's still distortion underneath the overhang of the part, and you can still appreciate the single layer of material serving as the brim at the base of the part. Just like the former piece, we're going to need to break this one open to really get a sense of what the top to bottom thickness variable means. So here, you can start to appreciate that the thickness of the shell on the top is larger than the thickness of the shell over here on the side of the part. So really you can start to understand that Cura breaks down 2 different types of planes for the shells, the vertical plane and the horizontal plane. Top to bottom thickness refers to the top and bottom of the part shell, whereas wall thickness refers to the horizontal thickness of the shell. So next up is altering the infill density. We'll beef it up to 60% to stick with the factor of 3 theme today. And you can see the outside is really unaffected to what we can tell, aside from the fact that we used support material on this one to appreciate the lack of sag at the bottom. You still have that single layer of brim there, but to really understand the infill density, it's all about what's going on the inside of the part within the shell. So let's break it open like we've done before and see what we can find out. So interestingly, you can see you have a similar effect to what happened on the bandsaw. The infill density of 60% is so high that even with the handsaw, it causes enough heat to have the adjacent layers melt to one another. So because that's not very helpful, I took a video while I was printing at 60% infill density, and as you can see here, I hope you can appreciate it's very dense. Most parts don't require density this thick, and keep in mind that the more density you add to your part, the longer it'll take, as you see here, and the more material you use. So keep in mind when selecting your infill density that this decision doesn't have to be an all or nothing one. So next up is choosing a skirt as a base, and the part is really not going to look much different aside from the lack of the brim, and that's because the skirt is left on the tray. So as looking at the picture here, you can see that the skirt is in line with almost exactly the way that Cura describes it. The skirt is a line printed around the model, but not connected to the model. I found this to be a little ambiguous without seeing it firsthand, so hopefully that helps to clarify it for you too. Next up is using the raft as a base. We've seen this before in former videos, but as you can see here, the raft is primarily a thicker, more sturdy adhesion type to the build plate. Comparing it side by side to our first print, which used a brim, you can see not only is it larger, but also you can appreciate that it's thicker. So this concludes our two-part series on the instructional videos for the Ultimaker 3D printers. Hopefully it helped you not only gain a better sense of familiarity with the Ultimaker, but with the general 3D printer software that has similarities across various platforms. As always, never hesitate to reach out to your professors or TAs with any questions, and in the meantime, happy prototyping.